HVAC temperature rise formula to measure airflow cubic feet per minute. Calculate airflow using electric strip heat by measuring precise voltage at the heater taps, true amperage on each heat circuit, exact temperature differential between return and supply air, and correct total electric heat wattage while accounting for line voltage, phase, and watt density. Before applying the temperature rise formula, verify which heat stages are energized and lock them on so your load is steady and not staging in and out. Use a true root mean square meter to measure voltage at the strip heater taps under load, because nameplate values can be off by 10% or more once the blower and heat come online. Clamp a true root mean square ammeter on each individual heater leg, then sum the currents if there are multiple strips or stages, since shared neutrals or multiple contactors can hide a partial failure. Compute total electric heat wattage using W equals V times A, stage by stage, and subtract any non-heating loads on the same circuit so you do not inflate the wattage. Allow the system to run for at least 10 minutes to stabilize, then measure the return air temperature 2 to 3 feet upstream of the blower, and the supply air temperature 6 to 10 feet downstream of the heater to avoid radiant heat skew. Average multiple points across the duct to account for stratification. Record indoor barometric pressure and elevation if possible to refine air density. If not, assume standard density, but note that high altitude will reduce density and change the cubic feet per minute results slightly. Confirm that filters are clean, registers are open, and the blower speed tap matches the heating speed you intend to test, because restrictions will raise temperature rise and make cubic feet per minute look falsely low. Finally, use the airflow formula. Cubic feet per minute equals 3.16 times total electric heat in kilowatts divided by temperature rise in degrees Fahrenheit, where 3.16 is the conversion using standard air density. For non-standard conditions, adjust density or use psychrometric correction. One of the biggest mistakes in HVAC airflow testing with the temperature rise formula is using nameplate voltage and nameplate kilowatts instead of measured line voltage and true amperage, which wrecks heating wattage accuracy and yields wrong cubic feet per minute. The fix is to meter voltage at the strip taps and amperage on every energized leg, then compute real kilowatts from V times A for each stage. Another common error in airflow measurement for furnace temperature rise is taking supply temperature too close to the heater or at a single point, which exaggerates temperature differential and underestimates airflow. The fix is to measure downstream beyond the mixing length, average multiple supply points, and average multiple return points for a stable delta T. A third frequent issue in HVAC troubleshooting is testing during transient conditions, like when strips are staging or the blower speed is wrong, leading to fluctuating temperature rise and unstable airflow calculations. The fix is to force a steady stage. Verify correct blower tap or programmed speed. Wait for thermal equilibrium and log temperatures and amperage for at least 2 minutes before computing. BigHomeProjects.com lists vetted heating and cooling pros who understand airflow testing, electric heat staging, and temperature rise diagnostics, so you can find someone who will measure voltage, amperage, and temperature correctly the first time. Contractors use BigHomeProjects.com to showcase credentials, win qualified leads, and connect with homeowners who want precise airflow and comfort solutions from trustworthy local experts.